Hello guys, welcome to session 3. In this session, we are going to take a look at the OTV multicast mode configuration, and we will discuss some of the important tricks that you need to keep in mind when we are trying to set it up. Uh, so in the previous session, we had a look at the underlay where we have configured the unicast and the basic multicast infrastructure to route the multicast packets in the in the middle, right? And in this session, we are going to verify that our unicast, multicast, the basic infrastructure is already built. And then on top of it, we are going to configure all these edge devices as multicast overlay. For the example, I will show you the configuration of CSR11 and CSR21, which are the two edge devices for two different sites. And then we will we will check the basic connectivity between the host in site 1 and the host in site 2. After that, we will actually go to the unicast mode configuration in the next session. And once that is done, then we will configure the the secondary edge device as well, which is going to be your secondary edge device in each site. And then we are going to look at the routing part of it, which is how can you do the FHRP filtering to make sure your HSRP state is localized, and how can you do efficient optimal path routing. So we will probably need to get there in another 1 or 2 sessions to complete the whole package. All right. So we basically have configured these routers already, core switch 11, core switch 12, the host route here. We have done the basic OSPF configuration on the CSR 11 router and CSR 21 routers. For the join interface, we have not done anything on the overlay. We have not done anything yet on the LAN set interface configuration on the CSR 11. We are going to do everything in this particular session here. All right, so this is my host site 1, but this is basically simulating the client. I told you we are going to simulate two different clients, one in VLAN 11 and one in VLAN 22. So if you look at that here, uh, I have configured this, and I tried to configure default route, but let me remove that. I think we will do it in a different way. So let me remove the default route, and in fact, let me disable IP routing on this router because I'm going to simulate that just as a simple host. So instead, I'm going to configure IP default gateway only for this subnet 192.123.11, and my default gateway IP is the standby IP address, which is 254. All right. Let me make sure that, so if you go to the core switches, again, this core switches are core switch 11 and core switch 12 for site number 1. Similarly, it is core switch 21 and 21 for site number 2. So just to recap, we have configured HSRP for VLAN 11 and VLAN 22 on both these switches, switch 11 and switch 12. These are going to be the gateway devices. And also we are extending the layer 2 up all the way to the CSR, which are the edge devices of our OTV network. All right. The IP address of VLAN 11 and VLAN 22, let me see if we can ping them from our host. The IP address is 192.123.11. This is for VLAN 11, and 11 is the IP address of core switch 11. We can ping it. And now let's try to reach VLAN 22 IP address. Sorry, this is VLAN 12. All right. So you can see that we can reach both VLAN 11 and VLAN 22 IP address of both core switch 1 and core switch 11 and core switch 12 from the client. Similarly, if we go to host site 2, which is again, this is just a simulation of a host of a client, 192.123 and 11 This IP address here is 21 and this IP address here is 22. We will do for 21, 22, and if we do the same thing for VLAN 22, let me make sure I can reach them as well. So in a nutshell, looks like we have the basic connectivity from the host to the two edge devices, the two gateway routers what we have here in the same segment. But our end goal is to reach from this host to all the way to this host in site number 2, right? Now, if you look at the IP address configuration of show IP and brief, exclude unassigned, this is again the host in site number 2. It has an IP address 192.123.11.2. And let me do one thing. Let me actually hardcode the MAC address so it will be easy for us to understand. Let's say this is VLAN 11.0.0.0.2. And if we go to the host in site number 1, let me hardcode the MAC address. You can see that my IP address here is 11.1. So if I try to reach 11.2, you can see that I have no reachability. And that is because that these two hosts belong to two different sites, which are separated by IP network. And that's what we need to fix. So we need to breach that layer 2 in order to make sure that my host in site 1 can talk to host in site 2. So if we do a show IP ARP, it should be incomplete because my layer 2 is not extended yet. And this is what we are going to fix, right? Using the OTV. One, again, important point, I talked about it briefly in the first session. Here, when you configure the OTV, then you do not expand the spanning tree domain. So the spanning tree root for VLAN 11 and VLAN 22, it is going to be localized within the site, which means I will see one root breach for VLAN 11 and 22 in site number 1, and I will see a different root breach for the same VLAN ID 11 and 22 in site number 2. If you look at this configuration here, show spanning tree VLAN 11, you can see that this is the root breach, which is 2D00. And if you run the same command here, which is the other switch, core switch of the same site, you can see that these two switches, they agree on the root bridge. However, if you go to the core switch of site number 2, here the root bridge is different, 8600. But if you check the other core switch of the same site number 2, these two are same. So essentially, my root bridge election happens within the site because my spanning tree packets are not, are not going to be exchanged between the two sites. Again, in this case, yes, my IP network is still in the middle, and I have not configured the OTV. But what I'm trying to show you is that even if we configure OTV, we will find that the hosts are able to reach, those packets are being exchanged, but these spanning tree packets are not going to be forwarded by the OTV. So these outputs are going to be same even after the OTV configuration is completed. All right, so enough talking about the underlay, about the underlay multicast, unicast. Let's now get straight into the OTV configuration, what we need. So right now we are on CSR 11, which is this box here, and I'm going to configure this gigabit 2 interface as a LAN side interface. I need to make sure that I can receive the packets for VLAN 11 and VLAN 22, which are the two customer VLANs I need to extend. And then we will configure the join interface, the overlay for the OTV. All right, so at this time, my gigabit 2 has nothing configured. What I will do is I configure interface gig 2 and I need to configure service instance. This is for VLAN 11, encapsulation.1q 11, and let me give a bridge domain of, let's say, 11. Okay. I'm going to do the same thing for service instance 22. This is for VLAN number 22. Encapsulation.1q 22, I have to match with the VLAN number. And then let me put it in bridge domain 22. Okay. All right. Let me no shut the port. That's the basic configuration I have done. All right. I also need to configure spanning tree mode here. Now, at this point of time, if you check show spanning tree for VLAN 11, you should see that my spanning tree has kicked in, and I should see that this particular ASR is CSR is going to participate in the spanning tree here for both VLAN 11 and VLAN 20. Let's wait for these two ports to move into the forwarding state, and then we will learn the MAC address as well. Okay, going to the learning phase. Okay, finally we are into the forwarding state. If you do a show bridge domain 11, you can see that I'm learning the MAC address of my core switches here, and similarly for VLAN number 22. Very simple. As of now, nothing complicated. This is very simple EVC configuration. What you do on the ASRs or CSR routers. Now, for OTV, the first thing I will do is configure a OTV site identifier. As we discussed in the first session, each site should have a unique identifier, and this value has to match on both the edge devices of the same site. So in this case, I'm configuring only the one router per site as of now. So I'm going to configure the site identifier for site one router. I can give any name here, I mean any number, but for the sake of our understanding, I'm giving it 0x1. The next thing you configure is you do OTV site VLAN. We talked about this again in the first session. Here, this is OTV site bridge domain ID. Basically, each site should have one bridge domain that the edge devices will be using to talk to each other. If we go to the diagram here, if we configure bridge domain, let's say 99 or maybe 111 for site number 1, then that bridge domain will be used for CSR 11 and CSR 12 to communicate to each other about all the reachability, who is going to take care of the active role, who is going to take care of the standby role for the VLANs, or if this one of these two routers, they lose the overlay interface or the connectivity to the remote sites, then they want to make sure that the other router is able to handle all the traffic. So this entire communication, the internal communication, it basically happens through the site VLAN. This is very important. If you don't configure the site VLAN, your OTV is not going to come up. Okay. So I'm going to configure bridge domain 111. All right. And also I will need to create the instance under the LAN interface for bridge domain 111 because this needs to be in the forwarding state in the spanning tree. So let me go back to the LAN interface again, and let me configure service instance 111 Ethernet encapsulation.1q 111, and we will do a bridge domain 111. All right. We will also configure this VLAN 111 on both the core switches. All right. It is done. Now, if we look at show spanning tree VLAN 111, again on the edge device, it is now transitioning from the blocking to the forwarding state. So that is one part of it. Now we will go to the overlay configuration. Before we configure the overlay, let's take a look at the join interface. Again, we have already explained, we have gone through this, but this is the configuration of what we have, which is facing my transport network to the other sites. Okay. We will need to configure one overlay interface. This is pretty similar to interface tunnel 0 in GRE, or maybe interface NV1 in VXLAN. This is just the logical representation of your OTV interface. We configure OTV join interface, and we have to define that which interface I need to use to talk to my other sites, right? In this case, this is Gigabit Ethernet 1. We need to configure OTV control group. Because we are running the OTV in the multicast mode, we need to use two groups. One for the control group, where your ISIS packets and all the control packets will be encapsulated too. And we will use the data group, where your any multicast packet in the data plane needs to be encapsulated, and that will be using that particular group. So for OTV control group, you can use any group which you want. I'm using 239.111. You can use 777, whatever you want. Okay. I'm going to use OTV data group. And again, this needs to be a range of group addresses. So I'm going to use 239 dot, let's say, since this is for site number 1, again, we have to match it. So I'm using, for example, 239.100.100.0/24. You can use anything you want. After that, we also need to configure a service instance, where basically we will need to extend the VLAN IDs of the LAN side, which we basically wants to bridge between the sites. In our case, the two VLANs that we are going to bridge, VLAN 11 and VLAN 22, I need to configure it here. So I'm going to configure service instance 11, Ethernet, encapsulation.1q11 and bridge domain 11. I'm also going to do the same thing for VLAN number 22, encapsulation.1q22, and bridge domain is 22. Remember that the side VLAN is not going to be configured on this interface, because you do not want to extend your side VLAN. The side VLAN is something local to the edge devices. You only extend the LAN side VLANs which you where your customers want to extend the fabric for. So you configure the side VLAN only on the LAN side. You do not configure on the LAN on the OTV overlay interface. All right. Let's see what we have configured here. So as of now, we have configured the control group, we have configured the data group, we have configured the join interface, we have extended the VLANs. Am I missing something? Before I bring up this interface, I of course have my spanning tree converge for the side VLAN. Okay, that looks fine. Let me bring up the overlay interface now. I think that's pretty much all we need to configure. Let me do a no shot. Okay. You can see that my overlay interface is now up, but if you do a show OTV, it says that is it forward capable? It says no. So this is very important. I need to make sure that this is forward capable. It says that AED capable. It says no. The overlay DIS is not elected. So this is your designated intermediate system. It says that this is not elected. It is telling this is the control group I have configured. This is the data group what I have configured. It says that this is my join interface, which is going to be the interface to talk to the other sites, the physical interface IP address. This is my own IP address, the join IP address. It says the encapsulation format I'm using, GRE IPv4. This is my site bridge domain. It says I am multicast reachable. But as of now, my tunnel is not up yet. You can see show OTV. If you do a show OTV VLAN, you don't see anything at all. If you do a show OTV ISIS neighbor, there is nothing configured yet. So what we can do is now let's go to the other side, one of the router on the other side, which is CSR21, and let's try to configure the same thing there as well. So I'm talking about, as of now, we are done with this part here. Now I'm going to CSR21 here. All right. So on the CSR21, here the LAN interface is actually gigabit 1. So I'll go to interface again. I need to configure spanning tree mode PVST. Interface gigabit 1, no shut, service instance 11 Ethernet, encapsulation .1Q 11, breach domain 11, and the same thing needs to be done for VLAN 22 as well. Encapsulation .1Q 22 and breach domain going to be 22. Also, we are going to configure a side VLAN. So let me configure this now. The side VLAN here I can configure 2 to 2. Okay. All right. I'll go to the core switches here and I'll configure VLAN 22 in the layer 2. Again, this is just for the communication of the side VLAN. Otherwise, we don't need that. All right. So you can see that my LAN side interface is pretty much configured on the CSR21. Now I need to configure OTV site identifier. Here I'll give a name 0x2. I'll configure the OTV site breach domain 2222. That's what I configured in the LAN side interface. Okay. And now I'm going to configure interface overlay 1, which is going to be my join interface. I will do OTV site OTV join interface. In this case, my join interface is gigabit 2 because this is the interface which is going to the transport, the DC interconnect to the other sites. I'm going to configure gigabit Ethernet 2. The OTV control group, I need to use the same control group as I have used on the other site, which is 239.1.1.1. I need to use my OTV data group, which is 239.100.100.100, sorry, 0/24. I will configure the service instance, which means I need to extend the VLANs like exactly what I did on the other side. Service instance 11 Ethernet, encapsulation .1Q 11, breach domain 11. Similarly, I will do the same thing for VLAN number 22, which is service instance 22 Ethernet, encapsulation .1Q 22, and breach domain 22. And of course, we are not going to extend the side VLAN on the OTV overlay interface. That was specific to the LAN side interface. All right. If we look at show spanning tree VLAN 11, I want to make sure that this is in the forwarding state. Same for the side VLAN. And now look at the OTV overlay configuration. I have configured the control group, the data group, the join interface is there. I have configured the two VLANs that I'm trying to extend. Trying to extend over the sites. And now this is the time for me to bring up the overlay interface. All right. So at this point of time, my CSR11 and CSR22, which are the two different edge routers on the two different sites, I have brought up the OTV. I have configured the LAN side interface. Now, if we go back here to this router, and if we do a show OTV, it says that it is still not forward capable. The AED capable, it says no. LSP DB sync incomplete. So it is still trying to synchronize. Let's wait for some time. Now you can see something changed. It says now that since the LSP database synchronization is completed, now it is forward capable. It says yes. It is also telling that I am AED capable, which means I am the authoritative edge device. And again, I don't have any second router configured yet as in the same site in the overlay. So there is no primary and secondary. And looks like everything is fine. So if I do a show OTV ISIS neighbor, Now I am expecting to see my peer ID here, which is CSR21, and sure enough, I can see that. If you do a show OTV ISIS, uh, before I do that, let me do a show OTV VLAN. You can see that it shows both VLAN 11 and VLAN 20 is currently inactive. Basically, this is because of a timer. Whenever you bring up the OTV interface, it needs to go through a certain timer before it can start forwarding packets for VLAN 11 and VLAN 22. It's a long timer that you need to wait for. If you have a secondary device configured, and if there is a node which is failing, you do not need to wait for this timer to expire to do the failover. However, when you try to bring it up for the first time, or whenever you do a shut no shut on the overlay interface, you need to wait for this timer to be completed. And we have to be patient to bear with this. um, and as of now, if you do a show OTV ISIS route or database, you can see that I already got something. But if you do a show OTV route, I don't have anything yet. And that is because my VLANs are not yet in the forwarding state. So if everything is correct, then I am expecting this to uh, state information for VLAN 11 and VLAN 22 to move into the forwarding state. The same thing here. If you do a show OTV, I'm sorry, if you do a show OTV, it shows that it is all up. That this is forward capable. This is the control group. This is the backup information. The join interface, it is what is the encapsulation type. It says I'm multicast reachable. But when you take a look at show OTV VLAN, it says the VLAN is inactive. Okay. One more thing, if you do a show OTV site, it will tell you the site information. If you had one more device here, which could be the secondary, in that case you would have seen that as well. But here, since I do not have any, I'm only seeing myself here in this router. Okay. So when you do show OTV site, you see any other router in the same site, and when you do a show OTV ISIS neighbor, you are expecting to see the peer devices on the other sites across the DCI interconnect. All right, this is still inactive. Let me make sure my spanning tree is all doing good. Yeah, so at this point of time, you do not want to shut no shut or overlay interface again, because if you do that, the timer will be restarted again. So we have to be patient. We have to wait for approximately 4 minutes of time um, to to give it enough time for this to be in the forwarding state. Okay, here you go. So finally, now you see that this router, this edge device is telling I am the active forwarder for both VLAN 11 and VLAN 20. If I configure a secondary router here, which we will take a look at that in the next section, after the unicast configuration mode, then you will see that it is being load balanced. So if one of the node device is forwarder for VLAN 11, the odd VLAN, then other device will be the forwarder for VLAN 22. Okay. All right. Now, if you go to the other router, you should see the same thing. It says that it is active VLAN. Now, if you do a show OTV ISIS, show OTV route, you will see all the MAC addresses being learned here from different sites. Whatever you see with the service instance number, this indicates this is local to you. And whatever you see with ISIS, that indicates it is remotely learned through the ISIS process. You can specify the bridge domain. This is for bridge domain 11. If you want to look at for bridge domain 22. So this basically tells the remote side routes here. And one thing you will notice that I have not learned the routes for the actual host. Again, this is router in my example, but I'm simulating the router as a host. And if you remember, I configured the MAC address of 0001 and 0002. I am not seeing any of those. I need to initiate some kind of traffic, and if everything is all right in the data plane, I'm expecting that to be learned here in the ISIS process. So, few important commands: show OTV. It is going to tell you the state information. You do a show OTV site, it is going to tell you the site information. you do a ShowaTV VLAN, it will tell you all the VLAN information that you have forwarded on the overlay, and it will tell you who is the active forwarder for which VLAN. In this case, my router is active forwarder for all the VLANs since we do not have a secondary edge device. Then you do a show OTV ISIS database, and you can see that I'm seeing here CSR 11, which is myself. I'm seeing CSR 21, which is the remote edge device, and this is CSR 2101. This is basically ISIS designated intermediate system. If you don't know about ISIS, then don't worry. This is just working at the back end. But if you know ISIS, then you know what I mean by that. If you want to look at the detail of it, show OTV ISIS database, and if you want to look at the routes being learned, you can do this. You can do a detail of it, and you can see all the different MAC addresses being learned or different MAC addresses being advertised by those peers. This is pretty similar to how ISIS works. The only difference is instead of telling about the prefix information, it is telling about the MAC information. As simple as that. All right. So now let's do some verification here. Here at this point of time, you saw that previously I was not able to ping 11.22. Now let me initiate the ping again. Oh, you see, it is now working. And if you do a show IP ARP 192.123.11.2, you can see this is the actual MAC address of the device, which means my ARP packet actually was breezed all the way through the DCI interconnect to the IP network to the other side, and then the reply came back, and this is what I'm learning here. So if you ping now, you should be able to reach it perfectly fine. If you also ping the other side in VLAN 22, even that should also work. Let's confirm that. Yes. Now, if you go to the OTV router, and if you do show OTV route for bridge domain 11, now you will see that these two MAC addresses are present. 0001, which is my local MAC address. This is learned through my service instance. And then this is 002, which I learned remotely through ISIS process. Now, there is one interesting point here. If we do a show OTV ARP cache, you can see that whenever it receives the ARP response, it is basically going to cache the information in its own local table, which means if there is any other host in the same network, in the same site, who is also trying to resolve the ARP for the same remote gateway, sorry, the remote host, in that case, my edge device doesn't need to forward the ARP packet again, doesn't need to multicast that ARP packet again. In that case, it can respond to that particular host locally because it already has the cache information in its local cache. It says that you can see 11.2 is mapped to MAC address 002. So this is the beauty of OTV. This is how it also limits the bump traffic, which is broadcast, unknown unicast, and multicast traffic. If time permits, in one of the next session, we will take a look at some of the packet captures as well. In fact, we can take a look at that. In fact, we will take a look at that in the packet tracer tool section. I will show you the very last session how to see the packets in the packet tracer tool. How can we interpret the packets in the Wireshark? I will explain all this in the very last session of it. But as of now, you can see that in the multicast mode, my basic layer 2 connectivity is all working fine. What next? Okay, one more thing I wanted to show you before we conclude the session. This is my ISP1, which is the router as a rendezvous point here in the middle of it. If you want to look at the transport of it, if you do show IP mroute, you can see that this is the control group information 239.1.1.1. You can see that the control group information is formed, and both of the routers, they basically send the information. So whenever these two routers, the edge routers, they're trying to exchange the ISIS packets, it is being sent to a multicast IP. They're putting that ISIS packet into the multicast IP, which is the control group IP address 239.1.1.1, and then I'm going to send it to the transport network. My transport network should be able to route that packet correctly, and that's how my ISIS adjacency is going to be formed. So this is very important. And here you can see that for this G group, when it is coming from 21 router, which is site number 2, it is telling this is my outgoing interface. And similarly, when the same group information is coming from the other router, site number 1, it is going to Ethernet 000. So this is how your underlay multicast is working, and that's why it is absolutely important for the underlay multicast to work perfectly fine to make your OTV work in the multicast mode. If you were trying to send a multicast packet in the data plane from this host to the other host, then you will see that it is using one of the group information that you configured in the multicast data group range, which we have defined on the OTV overlay configuration. That being said, that's pretty much it from this session. In the next session, we're going to take a look at the OTV in the unicast mode, and then we will slowly move to OTV with the redundant adjacency server nodes, and then filtering, and then packet capture, and quite a few other stuff there. So thanks very much for your time. We'll see you in the next session. Thank you.